In this video, we're going to practice writing the equation of a line of best fit for a set of data given in a scatter plot. So here we're going to practice actually using real-life data to create a scatter plot and then draw a line of best fit. So the first thing we're going to do is we're actually going to create that scatter plot so that we can draw a line of best fit. So I need to plot each point, noting that on the x-axis I have cups of coffee, and here on the y-axis I have number of hours of sleep. So here I have 1, 7, 1, 9, 2, 5, 2, 7. So I've done these points to start. I then have x is 3, y is 8, x is 4, y is 4, x is 5, y is 6, x is 6, y is 4, x is 7, y is 5, x is 7, y is 2, x is 8, y is 2, and x is 9, y is 3. So there I have my data plotted. It seems to have a general trend, and what I notice here in step 2, it says decide if it can be modeled by a line and is there a correlation. What I see here is that there is a negative correlation. As the cups of coffee increase, the hours of sleep appear to be going down. Now from here, we're going to draw our line of best fit, and what I strongly suggest is that you utilize one of those see-through rulers and that you actually kind of take that ruler to the data and you find a line that you can create out of 2 points that best models the data. Now when we're drawing a line of best fit, we want to have some points above, some points below, and we want it to go through at least 2 points on our graph. If it goes through more, that's great. So utilizing my ruler, I draw a line that goes through this point here and this point here. So I'm utilizing the point x is 2, y is 7, and I'm utilizing the point x is 6, y is 4. So I'm going to use a straight edge and draw my line through those 2 points. And then notice here that I've got about 5 points below, 5 points above, and it goes through 2 points. So this is a good, solid line of best fit that models the data. Now, sometimes you may pick different points. That's okay. That's why it's so important to show these are the 2 points that I picked, and then to actually draw your line through the data and make sure you have points above. So here I have 1, 2, 3, 4, 5, and points below. So I have 1, 2, 3, 4, 5. Now what I'm going to do in step 4 is I'm going to write an equation using the 2 points that are on the line. So here I'm actually going to write an equation for my line of best fit. I'm going to utilize the points 2, 7 and 6, 4. Now I know that to write an equation of a line, I need to have a point and a slope. And here I see I have a point, but I don't have a slope, so I need to find my slope by using my slope equation. So I'm going to take y2 minus y1 over x2 minus x1. So here I have negative 3 over 4 as my slope. And then I'm going to move down a step and I'm going to actually write the equation of my line by utilizing 1 point and 1 slope. So I'm going to use this point here and my slope. So I have y minus my y coordinate is equal to negative 3/4 times x minus my x coordinate. I then want to rewrite this into slope-intercept form because that's the easiest form to utilize a line. So I use keep, change, and I distribute. So I have y minus 7 is equal to, we have negative 3/4 times negative 2 over 1. So negative times a negative is a positive. That becomes 6 over 4 or 3 over 2. So here I have negative 3/4 x plus 3 over 2. I then need to get y alone, so I add 7 to each side. And I have y equals negative 3/4 x plus, I need to do some fraction math here, so 3/2 plus 7. There's two ways you can do this. You can either turn 3/2 into a decimal, so that would be 1.5 plus 7, which added together, you would just say plus 8.5. The other option is you can keep 3/2 as a fraction and turn 7/1 into a fraction. Then you get 3/2 plus, we need to multiply it by 2 to get common denominators. So 14/2, then added together with 3 would be 17/2, which if you divide 17/2 is the same thing as 8.5. So you could either write y equals negative 3/4 x plus 17/2, or you could write negative 3/4 x plus 8.5. Either answer would be okay. Ultimately, your equation using those 2 points will be about this line of best fit. It should be something similar. It should have a negative slope around negative 3/4 with a y-intercept around 8.5. And we can even see our line crosses at the y-intercept at about 8.5. So what we're going to do here is we're going to utilize this line of best fit to make predictions. And remember from the previous slide that the x was our number on the x-axis, and those were our number of cups of coffee. And then the y was equal to our number of hours of sleep. So from here, I'm going to utilize this equation in order to make some predictions. So this first part says, how many hours of sleep would you predict you would get after 5.5 cups of coffee? Now, if I look over here at the right-hand side, I can see that x represents our number of cups of coffee. So in example 1, they're telling us that x is equal to 5.5, and we need to find the y value that pairs with that for this equation if we want to find the number of hours of sleep we predict we would get. So we're going to take our equation here, and in place of x, we're going to substitute the 5.5. So here I have y equals negative 3/4 times 5.5 plus 8.5. And then from here, I just follow the order of operations. Negative 3/4 times 5.5, using my calculator, is a negative 4.125. We then add that together with 8.5, and we find that we would predict we would get about 4.375 hours of sleep if we drank 5.5 cups of coffee. Now on the flip side, if we look at example 2, this one says if you slept approximately 7 hours, how many cups of coffee would you predict that you drank? So if I look over in what I have in red, I know that y is my number of hours of sleep. So here this problem is telling me that y is equal to 7. So what I'm going to do here is I'm going to substitute 7 into my equation in place of y. So I'm taking the same equation here, but replacing y with 7. So then I have negative 3/4 x plus 8.5. Now in order to get the x value by itself, I need to start by subtracting 8.5 from each side. So I have a negative 1.5 is equal to a negative 3/4 x. Almost forgot that. Then from here I need to get x by itself, so I'm going to divide both sides by a negative 3/4. Now this might look a little bit tricky, but negative 1.5 divided by negative 3/4 I know is really negative 1.5 times 4 over negative 3. I can put the negative 1.5 over 1, so 1.5 times 4 divided by that 3. I know that I have a negative times a negative, so I have a positive 2 here. So as a result, I then find that x is equal to 2, and then I think, okay, what does that 2 stand for in terms of the problem? Well, X is my number of cups of coffee, so this is telling me that if I got 7 hours of sleep, odds are that I drank 2 cups of coffee.